So our objectives today are problems and distinguish, which means determine or decide which one is a combination and which one's a permutation, which one or the other. So does order matter or does the order not matter? If the order matters, you say permutation. If the order does not matter, you say combination. And that is the difference. The way I like to think of it is if you're in a race, like say all 5 of you got in a race, and I gave $5 to the first 2 people that finished. First place gets $5, second place gets $5. You would not care if you came in first or second. You'd be happy either way, right? So I would call that a combination. However, if, say I gave first place $10 and second place $5, then you would care that you came in first, and the order is important. So let's just go through and notice all it says is labeled as a combination or a permutation. 70 people run in a race. The first 3 people to finish get to stand on the podium to get recognized. So they get to stand on the podium to get recognized. How many people can stand on the podium? So what do you think? Does order matter or not? Huh? Yeah, I would say it does not matter. You all 3 get to stand on the podium. Okay. Now sometimes podiums, one is raised up higher than the other, so maybe then it matters. But assuming that the podium is just flat, then I would say, who cares where you stand on the podium? You were one of the first 3 people. So yeah, this would be a combination. And it didn't say to do this, but what you would do is you'd say 70 people, and instead of using a P, you would use a C, and you would pick 3. Okay, 70 people racing, 3 people placing. Same scenario, 70 people in a race. The first 3 people get a gold medal, silver medal, and so does order matter? Yeah. Because one person gets gold, second place gets, third place gets bronze, and the rest maybe get participation trophies, okay? But yeah, I would say this is a permutation. Now that's all they asked for, was is it a combination or permutation? But we would set that up as 70 P3. See the difference? Right? And then, I'm kind of an overachiever. But notice the difference. If I do 70 C3, that's 54,740. And if I do 70 P3, that's way more. Why do you think there's way more combinations of, I shouldn't use that word, why do you think there's more permutations than there are combinations? Why is this number bigger than that number? What do you think? Yeah. It's harder to come in first than it is to just place, right? Plus, if you all got in a race and Asha, Christina, and Jada, you all came in the first three, well, here, you all just get to stand on the podium. So if Christina finished first, then Jada, then Asha, or Asha, Jada, Christina, it wouldn't matter what order you finished in, you all get to stand on the podium. So we could take out any combination of you three, first, second, third, or maybe your first, second, third, or your first, second, third. So we could divide out the combinations that are the same. Does that make sense? All right, I'm not going to write down the numbers for all of them, because all they said was label if it's combination or permutation. So I'm just going to label. So how many ways can Jake choose 5 different candy bars from 20? Would that be a permutation or a combination? Permutation? So if I have these pens and I pick 2 of them, and those are mine, I get to keep them now, right? Was there any significance to me picking up the red pen, then the black, or black or red? Did it matter? No, I get to keep both, right? So it's kind of the same thing. We did have a problem Tuesday where it was asking about in what different orders can he eat the candy bars. So I would call that a permutation. But if you're just picking bars, I mean, there's no significance of which one you get to eat first, right? Does that make sense? So you still get both. So I would call this a combination. Baskin Robbins offers 31 different flavors of ice cream. John is thinking about making a bowl of ice cream that has 3 different flavors. How many different bowls can he make? So you go get some ice cream, maybe you put some fudge, some gummy worms, and some pecans on it. So ask yourself, does it matter what order you put your toppings on? Does it? I would say probably not. Now that's not always true. Sometimes you want to put one topping on before the other, but I would say this is more likely a combination. You get all 3 toppings on your ice cream no matter what. Right? Kind of like when you make a salad, you usually put the dressing on last, but there's no rule saying you can't put that on first. You still get the dressing, right? Blake is making a documentary movie covering 3 different celebrities, and he has 900 different celebrities to choose from. So how many different documentaries can he make if he only chooses 6? So he's going to make 3 documentaries. Does it matter? Does the order matter? Is there any significance to be chosen first versus second versus third? No. Unless you maybe want to be on TV first, right? But I would say it's more likely a combination. Notice I said more likely to be, because all you got to do is change a couple words, and now the problem changes to a permutation. Maybe the first person who gets chosen, maybe it's a bigger contract, right? And we don't know that. So all you got to do is add in a little bit, and it changes the whole problem. So based off what they said, combination. Sam wants to rank his favorite, second favorite, and third favorite celebrities. And there's around 900 celebrities he knows of. How many different ways can Sam rank his favorite, second favorite, and third favorite? Does order matter? Yeah, you have your favorite, right? If order didn't matter, you would be saying that they're all the same. They're all your favorite. Who cares? Right? So I would call this a permutation. So pay attention on the homework and in the practice. Sometimes they just want you to say, is it a combination or is it a permutation? Now, we have the combination formula. And notice, this and this is the same as yesterday. That's the permutation formula. Okay, it's only this part right here that's different. If you don't believe me, see, n factorial n minus r, n factorial n minus r, there's not an r, right? So it has an r factorial. This is kind of like when we were dividing out the extra letters in Mississippi. And we were saying there were 4 s's, so we divided out 4, remember? And there were, how many p's? M-I-S-S-I-S-S. 2 p's, so we divided out 2 p's. So you divide out r, which is dividing everything that is a repeat. Okay? Does that make sense? So that takes into account that order does not matter. So a teacher has 22 students who leave trash in the classroom. I'm going to guess we're going to use that, 22 students. The teacher chooses 3 students at random to stay after and help clean up. How many different combinations are there of students who stay behind? Does order matter? You got chosen to help clean up. Did it matter if the teacher chose you first, second, or third? No. You're one of the lucky people that get to help clean. It does not matter if you were chosen first, second, or third. Now, maybe it mattered too if you say, okay, first person, all you gotta do is wipe down the table. Second person, here's a toothbrush, clean off the floor. You know, maybe then order. But assuming that you're all just gonna clean, order did not matter. So we would use the C function. I would say there are 22 students. And we're going to use the C. And 3 of you are the lucky ones. And then just like yesterday, we still put this number on top. And then we still take 22 minus 3. Okay? All that's the same. But now you got to divide out because order does not matter. You see the difference there? That's it. Now, you know how to type that in your calculator. Because I'm a math teacher, I'm going to do it by. So 22 factorial divided by 19 factorial, that would equal 22 times 21 times 20. 22 factorial divided by 19 factorial. So to show our work, these cancel. And then for 3 factorial, we get 3 times 2 times 1. You see how I did that? Do the math, and you get 1,540 combinations. Any questions on how I did that? And again, you could just type that in your calculator if you want to. I just prefer doing it by hand. A person is dealt 5 cards. Okay? So we have 5 cards. from a standard 50 deck. While I'm thinking about it, 52 card deck, I don't know if you guys play cards, but it starts with the number 2 and you get 4 of those. The number 3, you get 4 of those. Number 4, you get 4 of those. There's 4 of every card. And you might have questions over that. And there's 4 of 5s, there's 4 of 6s, 4 of 7s, 4 of 8s, 4 of 9s. There's 4 10s, then there's 4 jacks, and then 4 queens, and then 4 kings, and then 4 aces. And usually in a standard deck, you have to take out the jokers. Okay, so there's usually not jokers. If you leave the jokers in, then there's more than 52 cards. So you may see problems with that. If you never play cards, you'd have no idea. But the order in which the 5 cards received does not matter. They tell you order does not matter, so it's obviously a combination. Correct? And it's true, if I give you 5 in poker, you can rearrange them in your hand. It didn't matter which one I gave you first. Okay? So, 52 cards. And you get 5 of them. Type it in your calculator or do the math. So this will be divided by 52 minus 5, 47. Now if this were a permutation, we'd be done. But combination, we also have to divide out 5 factorial to account that order does not matter. Doing the math, 52 over 47 factorial equals 52 times 51 times 50 times 48. Stop at 47. Stop before 47. And then I have 5 factorial memorized. I've typed it in my head so many times. That's 120. You're going to use that one a lot. 5 factorial is 120. 5 times 4 times 3 times 2 times 1. Okay. So after a while, you get some of these memorized. Do the math, and you get 2,598,960 combinations. Any questions so far? In December of 2009, the U.S. Senate consisted of 60 Democrats and 40 Republicans. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? Well, let's talk about the Senate first. Okay? Well, I guess the whole thing is the Senate. Let's talk about the Democrats first. We have 2 basically problems. We have Democrats and we have the Republicans. How many Democrats total are there? $60. Right? How many Republicans are there? 40. Now, you're making a committee. Does it matter what order you place them in for a committee? Does it? No. Is there anyone that's both a Democrat and a Republican? You have to pick one or the other. I don't know why it works that way, but that's the way it works. So, if you could be both Democrat and Republican, then that does change this problem. But you're either Democrat or Republican. There are other parties, but that's all we're speaking of. Okay, it's like saying boy or girl. So, of those 60 Democrats, how many people are chosen to be on that committee that are Democrat? Huh? 3. You want 3 of those 60 people on your team.